Hi, good morning, everyone. This is Nicole Testa Boston with FIATech. I want to welcome you to our 2013 kickoff of our Technology Tuesday webinars. Before I go ahead and introduce our speakers today, I wanted to go over briefly how to use the GoToMeeting system if you haven't done so before. That toolbar you see is unique to you, and at any time you can minimize it off your screen by clicking the orange arrow on the toolbar. You'll also notice that you are all on a defaulted mute setting. That's due to the number of attendees we have on the call today. However, we do encourage your participation and welcome any comments, feedback, or questions that you have. And to do so, you can use the Questions tab on that toolbar at any time during this webinar over the course of the hour. Those questions will come directly to me, and as time permits at the end of the session, I will facilitate a question and answer with our presenter. We also are recording the session, both the audio and the slides, and we'll be posting them in the next day or two on the FIATech website at www.fiatech.org. With that, I wanted to go ahead and introduce our speaker today, Dr. Scott Mason. He is the Floor Endowed Chair in Supply Chain Optimization and Logistics and a professor of industrial engineering at Clemson University. Prior to joining Clemson, Dr. Mason spent 10 years in the Department of Industrial Engineering at the University of Arkansas. He received his doctorate in industrial engineering from Arizona State University after earning a bachelor's and master's degrees from the University of Texas at Austin. Dr. Mason's areas of focus include operations planning, scheduling, and control of capital project supply chains, and large-scale systems modeling, optimization, and algorithms. I think it's also important to note that FIATech has an ongoing project working with Dr. Mason in this area. And joining the session today is Reg Hunter, who is a Senior Program Director for our procurement and supply chain areas in FIATech and also manages this project. So he'll be joining us at the end of the presentation to answer questions, and would be happy to follow up with any of you who'd like more information or how to get involved in the project. So with that, Scott, I want to thank you very much for making your time available to join us today and share this work with us, and I'll turn it over to you now.
Great. Thank you very much, Nicole. Thank you, everybody, for joining this morning. So the reason, hopefully, you're on the phone today is a couple facts that I think you'll agree with. There was a recent study by Marsh that said the construction industry invests only 0.15% of costs in material management and control versus 1% that's typically spent in basic manufacturing industries. In addition, CII, the Construction Industry Institute, estimates that materials and installed equipment in a capital project can comprise 50 to 60% of the project's cost, and more importantly, from what I'm talking about today, 80% of the project's schedule. If we take those two things together, Reg Hunter, who Nicole just introduced, came to me a while ago with an idea that he had figuring out, could we do some sort of predictive health monitoring for EPC projects, where EPC I'm talking about is engineering, procurement, and construction projects. Can we diagnose problems, if you will, before they happen? Is it possible to anticipate and identify when you might be going over cost or having schedule delays or any other undesirable situations before they happen, or at least better than you can right now? Because we know cost, quality, and schedule are all very key. What can we do potentially to help mitigate some issues with cost overruns or schedule delays from a predictive standpoint? And it was Reg's idea that was sort of the genesis of this project and this talk today. So in terms of what I want to talk about, I'm going to give you very briefly who I am, show you a picture of me in case if you care, give you an executive summary, what I think the punchline is, a high-level overview of what we're doing in terms of our methodology, but I really want to tie it to practical things you can use at your company. My goal is not to baffle you with mathematics or pretend to be smarter than you, because I'm not. I just really like working in this area. There's lots of great tools and people to work with, and I hope that by showing an industrial case study, talking about where we're going in the future, we can hopefully motivate your participation in our research efforts. So to get started, we'll very briefly give you the background. Nicole sort of read some of this. I have my degrees from Texas and ASU. I worked full-time in the semiconductor industry, and I think I'm very proud of that because as a faculty member, I enjoy having real-world experience to draw from and base my research on as well as extend my research into. I've been consulting since 1993, and like Nicole said, I was at Arkansas, and then in 2010, I was very fortunate to be the inaugural Fluor-endowed chair in supply chain optimization logistics at Clemson. Fluor actually partnered with Clemson University to endow this research chair because they saw a key need in the EPC space to bring industrial engineering-based tools and techniques and analysis, as well as supply chain teachings and findings and learnings to the EPC or the construction industry. So, why Clemson? Well, we have a lot of stuff going on here. Brief commercial, won't take too much of your time, but we have a variety of research institutes and centers funded by the National Science Foundation, funded by a variety of sources, the state, such that we have a lot of expertise in supply chain optimization and logistics that have been here for a while. And all three of these centers work together to become this aligned but diverse group of researchers and faculty who work in the logistics space, the supply chain space. And our work in the capital projects area actually led us to offer an online master's degree in the capital project supply chain. We do things in areas that a lot of companies face, whether they're military, healthcare, commercial goods, or the EPC or construction firms. We've done work looking at inventory levels, looking at transportation and distribution, outsourcing, a variety of areas that we believe touch many different industry areas. Of course, the proof in the pudding is I can tell you we did all this, but what I can tell you is we've done projects with a number of companies in these areas. So in each of these areas that I mentioned on the previous slide, these are just some example of companies we work with and done some analysis for. Because while there is a good need for theoretical research, I really get excited when the research we do can be implemented in practice and make a difference for companies. And so we sort of pride ourselves on that. Okay, so back to our big idea. So Reg came to me and said, what if we could predict when bad things were going to happen and fix them? And I said, well, from a logistics standpoint, what if we look at the in-transit information of stuff in a project being sourced, getting the PO cut, getting it to the shipper, getting it to the freight forwarder, delivered to the job site, a variety of different touch points or milestones in the life of an item in a construction project. What if we could study this information and statistically tease out or find patterns or things that are happening in the data that might suggest, using these advanced analytical techniques, what you could do about it before it happens? So sort of like trying to forecast the stock market. If we could do that, none of us would work for a living. We'd all just make all the money in the world. Well, this is a difficult problem as well, but we're trying to apply some pretty cool techniques to see what we can do with it. And I hope you find the results compelling. So what if we could benefit from making better decisions or more informed decisions if I looked at the scheduled date and the actual date for things like staging processes in logistics? So when the shipping request is received, or there's a free carrier available and it's ready to be transported. Because the companies that I've dealt with store this type of information where they have a plan and then they start recording when the actuals are happening. And if I can start looking at data, sort of a history of data as the project is evolving between scheduled versus actual, can I notice some things going on that I might be able to react to? Besides the staging portion, what about the actual transportation portion? Whether it's in transit or it's at customs or the time it's supposed to arrive at the job site. There's a variety of different milestones that different companies may track. I'm not suggesting these are the only ones. These are some key ones we sort of picked for our phase one proof of concept, if you will. If you look at an example item, here's a very simple scatter plot of a variety of those data points that I just mentioned. You'll see the legend at the bottom. But what you're looking at is the difference between planned and actual. So a positive number means it was later than I thought, and a negative number means it was earlier than I thought. And if I look at all of this data, all the way back to the shipping request notice to the estimated time of arrival on site, I can look at historical data and say, well, this data kind of looks flat. Maybe in this simple approach, this looks like things are okay. I don't see anything really starting to spike up in terms of a large deviation between planned and actual. Another item you might look at in the same project, what if I only looked at the staging data? If I look at the staging data, I see very flat, consistent data. It looks like the biggest deviation between scheduled and actual is less than 20 days. So again, I'm thinking, wow, these items are doing well. My project's tracking along nicely. Because in the staging portion, I have a nice, balanced, or flat deviation from plan. I'm adhering to my scheduled dates. But if I look at these same data items, the same item, and I look at the data for the transportation portion of its logistics, I see a different picture. Here I see over time the deviations from plan are really starting to grow. So these same items that were doing very well in the staging portions of their processing, getting them to the packer, getting them to the shipper, for some reason when they got in transit in the ocean, or they got to customs, or they got delivered to site, we can see we're starting to really have problems. When I see a 130-day deviation from when I planned it to be on site to when it arrives on site, this could be cause for concern. Well, this is a simple approach that I think people might be doing today. Sort of the idea of looking at instantaneously what's going on. What does the data tell me in terms of just simple shipment information? And I'm looking for what I would call a simple or linear trend here. Is it going up? Is it going down? Or is it remaining flat? Well, what are we trying to do in our project if I just showed you that? The idea here is that we want to monitor a project's health on demand as the project is elapsing rather than just looking back in time. How are we doing in terms of our on-time deliveries or meeting our project milestones? We want to be able to identify and actually make recommendations to take corrective action to respond to these anticipated or forecasted schedule delays or cost overruns. The idea here is we want to enhance how well we track along with the project schedule, with the assumption that if we can do that, it's going to help us lower overall project costs. Now, some of my industry experience tells me that when people aren't meeting due dates, they change the due dates. They extend the due dates so that they can meet them. And I'm not saying that's right or that's wrong. I'm saying it happens. But our idea here is, what can we do to try to adhere to our original due dates as well as possible? How are we going to do this? Well, we're going to apply some advanced statistical tools in our toolbox. And you don't have to worry. I'm going to give you a high-level overview of these because if somebody asked me once if it was my last day on the earth, what would I like to do? And my answer was, I'd like to go to a statistics class because those are typically the longest days of my life. And with that joke, I'm not going to give you too much statistics, but just enough to make you dangerous. So what we're doing, one of the techniques we're looking at is logistic regression. What you're looking at here is the idea of probability, yes, it's on time, or no, it's not. It's a 1 or a 0. It's a binary decision. We call that a categorical factor. So if I'm looking at, is an item going to be on time or not delivered to site, that is a yes or no answer. So we have a lot of continuous factors, like when is the pipe spool going to be delivered? We can forecast some period out in time. But the categorical analog is it going to be delivered on time, meaning by its due date, yes or no? If we use linear approaches like I showed you earlier with the simple approach, we're going to see that the linear is going to forecast values between 0 and 1, less than 0, greater than 1, because linear is applying a continuous technique, if you will, to a categorical factor. Whereas logistic regression is a way to sort of fit, is it yes or no? Yes, there's a little space in the transition here, but we want to predict the probability that something is going to be on time or not. So logistic regression is a way of doing this for categorical factors. Now, I wouldn't be a professor if I didn't throw some math at you. This is just to make you smile. Logistic regression, the key here is that it can work for a single predictor variable, like is it going to be on time at site? But what we're doing is what we're calling multivariate, or multiple different variables, because we want lots of different ingredients in our cake, if you will, to figure out what makes it taste the best. We want as many factors put in the model and let the model decide what do we need to use. The second technique that we're looking at is artificial neural networks. The idea of artificial neural networks comes from how the brain works, and I'm not a brain surgeon, so I will try to make this as painless as possible. But the idea here is that we learn from experiences and things that we observe. We learn from complex, both linear and nonlinear trends, and we also, using artificial neural networks, can actually, in a very highly variable area or with only partial information, we can try to make decisions and predictions with this imperfect information. So in the brain, we acquire knowledge through a network, and we have these neurons that are used to store knowledge. And the people who develop this technique, I'm not them, I'm using an existing technique, sort of use the brain's function as an analog for how to do the math. The big key for you to know, again, is it extends to multivariables, multiple inputs. Because when I'm trying to predict if something is on time or not, I want to have as many possible independent or predictors that I want to put into it in order to get the most robust or the most accurate prediction of on-time delivery, if you will, as possible. These techniques have been used in many different areas besides just logistics and on-time due date assessment. We're using them today as our initial two statistical methods to try to see if we can tease any information out of these data sets. So what neural networks does, we're using it for classification. We're trying to assign data to a class, and I'm going to talk to you more about that in a minute. But as I was saying, there's lots of things neural networks can do. We're trying to figure out a class, and a class to us is on time or not. So when you think about how the brain works and how it mimics biology, the neural network basically takes different inputs. The key to this figure is the right-hand side. Different inputs with different weights or importances. It then transforms it with some mathematics, does some more mathematics to make a prediction, to make an output prediction. And our prediction and everything we're doing is, given all of these data points about was it on time or not when the PO is issued, was it on time or not when it was at the shipping dock, was it on time or not when it was being staged, etc. We want to use as many predictors as we can to figure out if we can estimate or predict with what certainty will it be on time at the job site. So our focus here is on the right side. So let's get started. We actually talked with a bunch of FIATech members. I did a presentation out in San Diego at the member meeting in October looking for some data sets, because we can come up with the coolest tool in the world, but if we don't have realistic data sets to analyze to see if it works, you wouldn't buy into it. You would say, well, you've made up all the data. Well, we asked them for things like, could you tell us, just for a set of items on a given project, how do your milestones set up? The people we talked to said, well, we have things like milestone targets and actuals for when the purchase order is issued, when it leaves the shipper, when it arrives at the freight forwarder, etc. Every company might have different milestones. This approach applies to any milestones we wish to evaluate, which is one of the strengths of it. The key here is we're looking for both the planned and the actual of any type of input or milestone or predictor that we're going to use. Today, I want you to consider a large data set of an EPC supplier that gave us the data, because we keep it all anonymous. We don't wish to tell anybody's business. But we extracted a little over almost 3,000 different items that go to this project. We asked them to scrub the data such that we did not know what the items were. We are trying to make this as unbiased as possible. But for these items, we needed these milestones that I talked about above. So basically, they sent us a spreadsheet through a secure connection. The data is housed in a secure place, and nobody will ever know who the company was or what we're doing with the data. But I hope you find some of their results compelling. So again, we're trying here to predict the future. So we have predictor variables that are trying to guess a response. So if we take these factors here. The price of an item we asked for. We asked for the difference between plan and actual, those positive and negative numbers. They gave us the raw numbers. We computed the differences. But to start, let's just consider for the sake of a simple example, these are 4 predictors. I want to know if I give you this information, whether it is on time or late for purchase order release, for item being shipped out by the supplier, and arriving at the freight forwarder. So this is well early into the logistics or the supply chain. We're only looking to the freight forwarder. I'm trying to make a prediction about on-time delivery at the job site. So there's many more steps before this, but obviously I want to try to see if early information can be useful for predicting the future. So our response variable is what we want to predict with good accuracy, because if our model works, we're going to be able to predict based on some early occurrences in the in-transit supply chain or the staging supply chain, are we going to be on time or late to the job site? So we're looking at quality control check at the job site, meaning it's already been delivered and it has passed QC. So we would argue that this is one of the most final milestones any item or piece of pipe or rebar or turbine or anything that's going to a large construction project would go through. So this is what our response variable is going to be. Well, we wanted to make it into classes. So we're going to say class 1 is it was on schedule or early. So meaning the actual is less than or equal to the planned day. Class 2, we realized we can't just say on time or late, because there has to be some threshold of, yes, it was a day late, but really that's not a big impact. So after talking to some people, we decided to say, for lack of a better term, nearly on schedule are things that arrive 1 to 7 days after the planned date. And finally, we're going to say class 3 is late. Anything that arrived after 7 days from when it was planned. And we're going to make these classes because we believe if something is 8 days late or it's 108 days late, it's late. Now you could say, well, that's not really true, Scott. There's different degrees of lateness. And I could buy your argument. But for, again, a phase 1 discussion here, these are the classes we're going to try to predict with high fidelity. So what are we doing here? Well, the logistics regression is actually built into part of a software called MATLAB. And we are going to come up, based on those initial predictors about the PO being issued, about it being arriving at the shipper, we're going to make a prediction as to whether this item is going to be on schedule, nearly on schedule, or late in that final QC check using that very early information. And what we have to do is, if the model makes a prediction, it's going to give us probabilities that it's going to be in one of those 3 classes. So we're going to say what the model says is the highest probability class is what we're going to make our prediction to be. So in other words, if the model says the probability it's going to be on schedule is 20%, the probability that it's nearly on schedule is 30%, and the probability that it's late is 50%, the prediction we're going to make in our methodology is that this item is going to be late, because we are trying to predict which class it's going to be in. We can't give you a halfway answer, sort of like a weather forecast, and say, well, it might rain. We're going to make the statement, yes, it's in one of these 3 classes. If there's a tie, if for some reason 2 classes are at 40% and one's at 20%, we're going to conservatively pick the worst case, assuming that it's not going to be on time, it's going to be a little late. So we're going to be conservative in our estimates in terms of our prediction. So with the neural network model, it's also part of this MATLAB software. And for the technology folks on the, or I'll say the nerds like me, we're using back propagation, feed-forward model. We have different numbers of hidden layers. We can talk offline about artificial neural networks until you want to go take a nap. But the idea is that we have to train the neural network model. So if you give me a set of data, let's say it's from a year, and I want to forecast my weight, I can build a model and say, you know what, I want to look at my weight from January to February and build my models around that. I want to use 75% as an arbitrary number that I like to use, but I want to pick 75% of the data where I know the answer and let my model try to predict it and compare the known with what I predict to sort of tune or teach my model how to be successful. Once I have trained the neural network to say, if you see these predictors, this is what's going to happen as the output. The model then learns how to predict, and then we're going to analyze the entire data set with this trained model. So we have to take a portion of the existing data to train, to sort of teach the model what to do, and then we're going to analyze the entire model to see how well we did. In every case, it's about measuring our error, because if we're trying to make a prediction, we want to know if we're right or not. So what I'm asking is, how many times did we predict an item's true delivery class? Because if I've given these 2,800 some odd items, I have all of the data. I have the data all the way through to that last QC check. But I'm not going to act like I do. I'm going to let my tools predict it and see how well they did. Because if we can develop a methodology that predicted what happened, then it can actually be instantiated or implemented in an ongoing project, and our assumption is you'll get the same type of accuracy. So we take our industry data set, and we take all of the data and we sort it by chronological order of the planned purchase order release date. We kind of build like a timeline history by the PO release date. We realize that there could be some stuff in a project where you have bad things happening at one stage in the project that actually impact the rest of the entire project. Maybe there's a strike. Maybe there's a natural disaster. So one thing we wanted to look at in our research is to sort of, how can we cluster or cut up the data? Can we do it in a smart way to see if we can find any outliers or bad data that might be throwing our models off? So these two types of clustering we call segmented, where we basically take these 2,800 records and we split them into 4 equal parts. So each part is 720 items. We look at each 720 items separately, and then we average the results together to say what our predictive strength is. Our cumulative approach looks at basically the first quarter of the data, then we look at the first half of the data, then we look at the first 3 quarters of the data, and then finally we look at all of the data. So we take different chunks or pieces of the information, and then we look at our average ability to predict it across the variety of types of data. So we have this large data set. We have these different approaches for segmenting or clustering the data. We have logistics regression. We have artificial neural network. We have all these different things that we're going to test out, if you will. So what we're trying to figure out is, what are the right predictors to include? Because just because I told you I have item price on site at the supplier, purchase order release, that's not necessarily saying we want to use all of them to predict. Well, the models use advanced analytical techniques to tell us what are the right predictors. So what you see here is our experiment of 12 different runs. And here I have the key for the predictors. Whether item price was included or not is a check mark. Whether or not the date the purchase order is issued is included is a check mark. So we ran different combinations of runs 1 through 6 that are using the segmented approach. Runs 7 through 12 are using the cumulative data approach. So we call this an experimental design. I'm running 12 different analyses of the same data and figure out, for the logistics model, logistics regression, and the neural network, how often were we wrong on average? And what you'll see here is for run 3, that happens to not use the price of an item as a predictor, but indeed uses the date the PO is issued, the shipping from supplier date, as well as the arrival at the freight forwarder. Again, early processes, early steps in the process. In a segmented data approach, we can predict the future on error with an error of a little over 8.5%. Another way to spin that positively is we predicted whether it was going to be on time or not over 91% of the time. This is for one data set, one set of runs. We're eager to continue to test other data sets and develop other methods, because we're not saying we can always do 8.65%, but this gives us good confidence that we might have something here. If we take a different view of the same results, you can look just for logistic regression, what segmented versus cumulative looks like with different factors, or for the neural network. Here's our 8.65 value we see. And on total, it's interesting to see that depending on which predictors you use, you can get 70% error if all you do is look at the date the PO is issued, but you can get 8% error if you include a couple more predictors. My assertion is that this data is available, and if you have the predictors, put them all in the blender and see what the model comes up with in terms of the right way to do it. So what does all this mean to you? If we look at our specific model for run 3, the one we thought was the best, we can say, based on what we predicted, if it's in class 1, 2, or 3, so that's the column, and versus its actual class, how were we wrong? In other words, this 50 in the table tells you we predicted it was going to be late, and it was actually on time. The 57 is we predicted it was going to be on time, and it was late. Different percent of errors occur depending on what the actual class is. My point is, I believe this upper triangle is the key area of focus, because if the 50 tells me I was worse than it actually happened, I predicted late and it was on time, I would love to live with that problem. The 57, however, tells me I said it was going to be on time, and it actually ended up being late. So depending on the 9%, the 11%, the 5%, this is where we get our about 8% average error. This is for the neural network model. Similar results can be flipped to say, how often was I right? So this is basically saying the diagonal. When I thought it was 1, it was 1. That was 900 times, 200 times, 1,500 times. So there's a lot of strength in our prediction model to see how well we can predict. This is what we believe, how well we can predict on-time delivery performance to a job site. This all here is for the neural network model. Similarly, we can show you the tables that result for the logistic regression model. You will notice that, for example, for some reason, it really did poorly for class 2, the nearly on schedule, in terms of getting correct. That's obviously something that we have to dig into more. But when we look at these two approaches, you see this performance of the 79.6% error for class 2. That's really skewing how poorly this logistic regression model did in run 3. So these are things that we would look at, and then we're going to dive in further to figure out what could we do differently to potentially make this approach more competitive. Again, I think the upper triangle is the key, and these numbers are a lot bigger than they were for the neural network model. So if today I had to make a final decision, I would be telling people the neural network is the way to go. However, we have ongoing research that conclusion might stick. It might change in the future. Which triangle matters to you the most is sort of an open question, because you might really care that I predicted late and it's on time because I'm in a just-in-time situation and I put a lot more expediting or resources or inventory behind it, so being early is just as much a problem for you as it is being late. You might care about only the upper triangle. This is subjective, but things like this are what we're looking for industry feedback on as we continue our research. So I'll end with a couple thoughts. So what? What does this guy have for me? Well, what would having the ability to predict, and I'll say a caveat, with 91% certainty, that an item was going to be on time or miss its final delivery milestone by more than 7 days do for you? Would you like to have that capability? Would you like to have that capability months ahead of time, I think is the big key. Because our initial research is using very early milestone predictors to predict something months ahead of time, with many other touches and many other steps in its process. Well, I think the answer is one of my all-time favorites that students give me. It depends. What kind of items are you talking about is a big question. Is the item on my critical path, or is it like bolts, something that I have plenty of? Or is it an item that many other items depend on it in terms of the work phase? If this item isn't in place, there's many other things that have to go on after it, and if this item is late, it's going to delay and have a sort of a cascading or a chain effect on everything else around it. These key aspects of which items they are is something we're focusing on in our future research, because as I mentioned, the first data set was sort of blind to us. It was just a bunch of items. when we gave this presentation in San Diego, that was one of the first questions is, well, you showed those charts. What item is that? Is that a pipe spool? Is that a turbine? Well, we're going to get into that because we realize what the item is completely matters. A suggestion we have for FIATech members, as well as people who might want to get involved, is we could test our methods on some of your data to see what the possibilities are. The more people we get involved, the more data sets we look at, the better our methods become, the more accurate our predictions become. As we mentioned at the beginning, we have an ongoing relationship with FIATech doing research. We finished phase 1 at the end of last year, and we're very thankful to begin phase 2 now. We're continuing to look at other approaches besides just these 2 statistical methods. We love to get valuable feedback as to what we're doing. And some great feedback we got was, hey, Scott, this is all well and good, but you're starting at PO issue. Why don't you go back even further in an item? What about when the requests for drawings are issued to the vendors? If you could get data all the way from cradle to grave of an item, what could you do with that information? And I said, wow, that would be very cool. And a large firm stepped up, and we believe in the next week or so we're going to be hoping to get some of this data to further expand some of our efforts. Another thing I think that's interesting that so far I haven't found anybody look at in the EPC industry, my background, I think about a bill of materials or precedence relationships. So in other words, this item relates to these different work packages, which relates to these different sub-assemblies. Well, if I could get that information in addition to the milestone, scheduled, and actual, I think we can have a lot richer in terms of research results because the relationship or the interrelations between items is a huge issue, whereas some parts being late does not impact you, but other parts being late could really jeopardize the whole project. If I think about and want to summarize sort of up our end game, we're talking about developing some kind of dashboard or visualization capability for the FIATech members that use our tool. Again, FIATech sponsored this research. We want to come up with 3 to 5, and those are just numbers that Mason made up, key factors or indicators that you want to track and monitor. We want to make a tool or a capability that analyzing data sets does not require a PhD in engineering or statistics. We want data in. People love spreadsheets. Data comes in spreadsheets. Our results come out in spreadsheets. The magic inside is what we were hired for. And we also think that, and I can't make this point strongly enough, the more modeling and data set testing that we do, the more effective and robust our tool is going to be that really can be representative and accommodate the variety of interest in the EPC domain. So we strongly encourage interest, participation, questions, etc. But the more things we get to play with in our sandbox, the better the end product's going to be for everybody. With that, I say that concludes my presentation, and I will turn it back over to Nicole.
Thank you, Scott, very much. That was a great presentation. I know there's been quite a bit of activity on the question and answer tab here, and Reg has been monitoring that through the session. So I'm going to turn this over to Reg and see if you can provide any clarification or share with the group some of what's been coming in.
Sure. Thanks, Nicole. First, Scott, thank you very much for the presentation. It's always difficult to talk about subjects like this and have people be able to really visualize. And when I talk to people about the concept, I use the example of like a musical instrument. If the musical instrument's tuned, you can really tell. You may not know exactly what note each string needs to be, but you can tell when it's out of tune. The notion sort of applies in this case to is the flow of materials and the disruption in the flow of materials, can it be used as an indicator to anticipate the likelihood of a project being under stress and consequently being in a situation of a cost overrun or schedule delays. And so it's pretty easy to ask that, but I mean it's been done. I mean there's applications for now on most iPhones and smartphones where it can recognize genre of music. If you just train it against other music, say this is country and western, this is rock and roll, you train it sufficiently, you can actually have it listen to new music that it's never heard before, and the application will detect and indicate what category it falls into, and you have a certain confidence related to that. And so perhaps that might help some of the listeners on this in this conversation kind of visualize what we're talking about. Before I get to the questions, the other things that relate to this is that what Scott's really showing is just the beginning of what potentially could be a very powerful tool for our industry and other industries, because you can start augmenting the basic concepts and training against more information. Like, I'm more interested in the arrival of pipe spools because they're an early indicator of stress during the early phases of the build-out. You can start categorizing different types of materials against that and training it. And we have had number of discussions with respect to that. So I'll just kind of highlight the questions that I've been looking at and responding to somewhat. One of the, there's some concern or there's some interest in whether or not how this would address BIM capability. Would you like to comment on that, Scott?
You said BIM?
Yeah.
Okay, so can you tell me what BIM is to make sure I'm on the same page with you? That's intelligent buildings?
Yeah,
it's building information modeling.
Okay.
So creating an intelligent data set.
Right, okay. I think this technique, this idea can apply in many different spaces. And if you have BIM information, the more data, the more possible predictors we can use, no matter what we're trying to predict, the more things you have at your disposal, the better. If I'm trying to forecast my weight and all I know is how much sleep I got at night, that might not be as rich of a prediction as I also can tell you what I had for dinner, how much exercise, etc. So the more inputs we have, the more predictors we have at our disposal, we can have a richer, more robust prediction of whatever it is we're trying to predict. So how the BIM can interface with this is not obviously clear to me, but I have to think that that type of situation works well with, in concert, this type of approach.
We also had some questions that were like, once you have this thing, this concept, and obviously the reports and all that stuff, how do you visualize going about nesting it into an existing process and providing runtime information with sufficient utility to be used?
Well, I would say my experience in semiconductors and other areas is that anytime we develop models or tools, we develop the proof of concept. Somebody decides, okay, I want to give it a go. And then if they have their own IT or IS group, we want to figure out where are the systems that you're capturing this type of information. If it's a material management system, an ERP system, I believe if the data exists, we can get to it such that this type of bolt-on or add-on technology or tool could be run ad hoc by anybody who has this desire to know, where it will pull in a certain set of data. You pick which items you want, and you would have this dashboard or this recommendation of a health of the project. I mean, if I could cook it down to a single metric, or like a thermometer, is the temperature normal? Is it starting to rise? Is sort of our ideas for what type of visualization can we come up with in phase 2. But this data typically exists in databases and corporate systems just as flat text files. And we can harvest that data, seamlessly pull it into the tool, and then get the answers basically ported out in whatever format makes sense. And I think that's a lot of we want inputs or participation from members in industry, because what we come up with, we want to be useful. If we develop this thing in a vacuum, short of Reg's great ideas, we might have something that's completely, perfectly not useful. So I see it as sort of a decision support tool that can be run ad hoc as part of ongoing processes, or a nightly batch job as reports. Those are all ways I've done things in the past. It really depends on how often and who wants to be looking at this type of information.
Great. Well, there was going through these questions here. There's another question that was expressed perhaps some concern about the magnitude of types of information that you're trying to cope with on the fly, and whether or not it would make sense to have some sort of hierarchical approach where some information could be key to giving you predictors with maybe a little more limited amount of confidence, rather than overwhelming processing resources in order to provide a much more detailed snapshot of what's going on, to kind of paraphrase what I think this message was about. Are you worried about bringing computer systems to its knees to provide runtime information?
I am not, and that's a very well taken point. We tell our students all models are wrong because they're not reality, but some are useful. the best model or a good model is the simplest model you can build that answers the question you're asking. So if I can build a model that has 4 predictors that gives me a 10% error, or a model with 150 predictors that gives me a 6% error, the question becomes, is it worth it to maintain all of that data and overhead for those 4 extra percent of a prediction? Well, time and individual personalities will tell, but that's an absolutely well-taken point. This technology runs on desktop PCs very quickly. So I'm not worried about bringing computer systems to their knees. I'm about thousands of items or records, because you can absolutely extract certain types of items. I could see people looking at only critical path items, for example, not looking at every item that's ever put into an EPC project. But part of our investigation is, what is the best / simplest set of predictors that you can get the most value or strength in prediction for a robust prediction from? I do not wish to have 550 predictor variables if I don't need them. So it's a very well taken point.
Yeah, and that kind of touched your critical path comment, touched on some other questions that came in as well. And you know, it's interesting because, you know, the industry obviously has a great deal of passion, especially since projects are becoming progressively more complex and larger, that you know, if you focus on the most critical things, if they're going to be delayed, obviously the project's going to suffer. And so balancing and weighting the critical path elements and the long lead elements against all the other stuff going on, how do you envision trying to balance that?
Absolutely, I agree.
Okay. I'm just thumbing through here. Sorry, I'm trying to read it on the fly. And yeah, they talk about suppliers as a variable. There's some, you know, how do you go? Would you? I guess you could infer supplier performance as a variable in the likelihood of the supplier being to let you down by the model.
Absolutely, because if you have a history with a supplier, or you have some, I mean, when people do their planning, they have some expectation of service level from all of their subcontractors, their suppliers. If you start to look at the data and model historically how well they can deliver, much like you see statistics online for what percent of the time is a certain flight on time or not, you can build that into the model or try to make sure to see, is that a key input? I mean, I could run a model with a given set of predictors and get an answer, and then add another predictor and see, did it get better? Because one of the things that we learned, we thought item price was going to be a big deal. It turns out it wasn't. But then as we talked to more folks, they said, yeah, but you have no idea about whether it's on the critical path or not. And we said, aha, you're right. The price is one thing. You would think something that's more expensive would be more critical, but clearly what's in the critical path is going to be a primary area of initial focus.
One of the things that's come up in the past, and all companies do, and everyone does things differently, but they talk about this notion of consumption of slack. So for whatever reason, during the negotiation perhaps, or during the scheduling and so on, there's this idea of we want to get it done by this date, but we have this much slack built into it. And as the project's under turmoil or for whatever reason, you start consuming that slack. And one of the comments that we got in was, how do you look at, this is a little bit different than the training thing that you and I have been talking about. What you want to do is you want to look at these prior projects with respect to things like consumption of slack as a means to essentially talk about the likelihood of compressing the amount of slack allocation on a project. And what are your thoughts about that?
Well, some of that work relates to other industries that I've worked in where people put slack in schedules in order to accommodate or buffer variability. Variability is when, real life happens when we're making other plans. We can plan for schedule dates, and then we start to see actuals, and for a variety of reasons, they typically don't line up. As we start to get closer to deadlines and we start expediting and slack gets consumed, there are lots of research looking at what's called resource-constrained project scheduling. Resource-constrained meaning we don't have infinite money or infinite amount of resources. Well, that's clearly the key. And project scheduling brings in the critical path nature and trying to figure out where if I pull something in or something pushes out in the schedule, how does that dynamically impact and or change my critical path? So there's actually quite a bit in that space looking at how the slack is consumed, how the slack is best planned, where you have slack that you might not need it, and that type of thing. Companies get pretty sophisticated with regard to how they actually lay down their schedule and then how well they adhere to it. question I've always had is, how often do companies go back and do sort of a post-mortem analysis with a project and say, okay, where did we do good in our planning and our slack allocation? Where do we need to improve? And that type of retrospective analysis can be useful in setting targets for the future. But there's a lot of experience and historical-based decision-making out of necessity, and I think one of the goals here is to start, and I think one of the reasons that Fluor decided to endow this research chair with Clemson, is to see, in addition to that excellent experience, what else can be brought to bear? What tools and techniques from a different realm, industrial engineering, can we bring to these problems to try to make us more effective, more efficient, more on time?
Great. Two more questions here. One is, it relates to your presentation being aligned with the schedule and focusing on that, okay? And one of the things that this person was asking about is, what are the cost indicators are you tracking? In other words, rather than looking at the time frames between when something was supposed to take place and when it actually took place and things like that, the question I think is looking at, well, what are the, if you were to think of it in monetary terms, how would you do that?
Well, it's an excellent question. I mean, this initial work was based on sort of the logistics piece or the logistics side. There are typically costs obviously associated with this. If I'm looking for a cost type of output classification, or if I'm going to use costs as predictors, I would definitely have to get more of those inputs into the model. If I wanted to try to predict the cost of a project, the set of indicator variables or the predictor that I would be using would be completely different than on time or not. I'd have a different set of, quoted price, actual price, those types of things. But this methodology would apply to that type of prediction as well. It would just come down to getting data to train the model to come up with the techniques. But costs are obviously a big part of it. Our initial focus here in phase one was sort of on the on-time delivery to try to mitigate cost overruns due to schedule delays. If we're talking about costs of items coming in above bid or different costs being incurred that we didn't expect, either due to scrap or rework or inventory, I think that's an excellent application of this tool. It's something we just have not considered yet.
Great. This last question I've got is a very good summary type question. What they're really asking about is, how do you establish your confidence intervals with respect to the prediction integrity? And obviously I know the answer, but in addition to that is that I think this drives home the point that we really need to have industry and member participation in this to develop models, because right now if you get up and say 8.5%, I think you have to qualify that with some sort of confidence interval on it. And so obviously you have to do validation. Besides training, you have to do validation, and the only way to do that is with historic data. So I was curious what your thoughts were about that.
Absolutely, because when we get these data points, if we look at 2,880 data points and I get 2,880 predictions, my confidence interval is going to be very small because there's so many data points. Typically, as you add more samples, confidence intervals will tend to decrease. But you can compute the confidence interval based on all of the individual prediction errors, yes or no. And I think the question's fantastic, and you're right, Reg. I'm not here to claim I've got the solution that's going to let you predict the future by 91% accuracy. This is an initial study, and the average value is 8.65% with this one method for this one model for this one data set. If I had to compute the confidence interval, I could, and I'm guessing based on the number of data points, it's less than plus or minus 1%. It's going to be very tight because I use so many data points. In the future, we want to be able, maybe not confidence intervals, but from a more pragmatic standpoint to say, hey, this is how I could be wrong, this is how I could be right, sort of those graphs I showed with the triangles, because besides just the average, I want to know when I'm wrong, how am I wrong? Am I wrong under or am I wrong over? Because that could be a way that we drive the model's, quote, goodness, unquote, based on feedback from folks is, I don't care about the average. I want to know how often I predict a class 1, meaning on time, and it's late, because I can't have that, or other aspects that are important. So I think you can compute the confidence intervals. I think they will be very tight given the number of data points, but definitely not giving a point answer versus a range of prediction capability. I would definitely tend towards the latter in our phase 2 work.
Great. Now, one of the visions that you and I had talked about in the very beginning would be to have a model that's fully trained and complete, and a scenario where an owner, for example, or an EPC has the model running in the background, so they get periodic reports or they have a dashboard that shows what's going on. And I could envision, and what we talked about was a scenario where you could get up and say, I have 90% confidence that this project will be classified as under stress and costs will overrun and schedule will slip based on this model's predictions. And obviously the project manager at that point would get probably a little angry with you and rehire the material managers that they just let go. But do you envision a possibility like that happening where you can just watch the flow of materials and have it be an indicator for you to be aware of what's coming in the future?
I think so. It depends on how often that information is updated in the corporate systems that we rely on to pull the data from. I mean, you could run this in an ongoing fashion, sure, but I don't know how often. I could see batch jobs running at night that move a bunch of data from disparate systems into the corporate server. That's when you'd want to run this tool. And I could see you coming to work at 8 o'clock in the morning and you see your project health report for a variety of your projects, and then you use that to figure out who you start calling and chewing on.
Yeah, I think that's great. And so we really need anyone who's participating in this conference call, as well as any of your associates or anyone that you know that's willing to share information. At Fiatech, we made great efforts to limit our access to your information. We want you to provide it directly to Scott Mason. Scott will work with you to scrub it and reassure you on how he's going to protect it. But we really want to be able to extract all your subject matter expertise and leverage all your historical data relative to this project so that we can come out with something that really has a lot of utility for our industry. So with respect to that, I really appreciate, Scott, you're driving this project forward, and it's pretty exciting stuff. Any other questions? I'll keep looking here.
Well, and I think one thing to add is Reg doesn't even know who I got the data from, and that's how serious I am about protecting what we get, because we realize even if it's scrubbed, it's not something we want to ever get out. So Reg doesn't even know where the data came from.
So good. And just send me an email if you have questions, or send Scott an email. We're more than happy to talk with you. And if you want to challenge us or make the product better or make the effort more focused, I'm really excited to talk with you about it. That's it, Nicole.
Okay. Thank you so much. I wanted to thank both Scott and Reg for joining us, and I also wanted to share with you as a final plug here some information on our technology showcase, which is coming up in about 10 weeks down in San Antonio. We have a great conference lined up. I think we'll be seeing hopefully Scott and definitely Reg, so you can follow up with them there in person as well. We've announced our keynote speakers. We're going to have Dr. Grotzinger, who is the Chief Scientist of the Mars Rover mission, joining us on Monday, an economic forecast by Honor Von on Tuesday, Dan Rome, who's the author of The Back of the Napkin and Blah, 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 What to Do When Words Don't Work on Tuesday. That's being sponsored by Emerson. And Ted Feigenbaum with Generation Empower speaking on Wednesday. We've received so many proposals for presentations. The committee's reviewing that this week and next, and we should be announcing our final agenda for the program the last week of January. So please come to the site. You can get to it off of the fiatech.org site and take a look, and we hope you can join us March 25th to the 27th in San Antonio. On our Fiatech homepage, too, you can also go under the events and webinars, and that's where you'll find a link to today's webinar and recording. Give us a day or two to get that scrubbed and posted online. And with that, I just want to thank everyone again. Thank you, Scott. Thank you, Reg, and I hope everyone has a great day. Thanks.
Thank you. Bye-bye.
Thank you.